Hello everyone, my name is Atul Kumar Singh. Today we are going to solve LeetCode problem number 9, that is palindrome number. So what is palindrome? So given an integer x, return true if x is palindrome, else return false. So palindrome means reverse will also give the same output. For example 1 to 1. If we reverse this, we'll get the same output 1 to 1. Negative numbers are not palindrome, so if we are getting minus 1 to 1, return false. Uh, if x is 10, we will reverse it, that is 1. So 10 is not equal to 1, so it's false. So let's try to solve this problem. So we have to return in boolean that it is palindrome or not. If it is palindrome, then return yes, it is true. If it is not palindrome, then simply return false. So we will firstly handle the edge case. If it is negative, then it is not a palindrome. If our x is less than 0, that is negative, then simply return a false. Okay. And what we will do, we will simply store the original number in a variable so that after computation it doesn't get lost. Int original will store x here. Then we will declare a variable reverse in which we will compute the reverse of this number x. I will compute simply. We will write a loop, while loop. It will run till our original number x is greater than 0. Every time we will extract the last digit from this x equal to x percent 10. This will extract the last digit, and our the reverse digit is reverse equal to reverse into 10 plus our last digit. And for every iteration, we'll divide the x by 10 to cut the number. And at last, return x equal to reverse. If x equal to reverse, if it's true, then return true. If it gives false, then simply return false. So how it's working? First of all, if x is negative, then simply return a false. We are storing the original number x so that after computation, x doesn't get lost. Now we are computing the reverse. So when x is greater than 0, it will run till x is positive. So we are extracting the last digit from the x. For example, x is 1 to 1. So last is x modulo 10 means the remainder. That is 1 to 1. The remainder is our 1. So at last it will store 1. Reverse, we have initialized with 0. Reverse will reverse into 10 means 0 into 10 means 0. 0 plus last 1. So here in our reverse it's 1. We are cutting the subspace. So now we have 12. We will do last. We will get 2. Then in reverse we have stored 1. 1 into 10, that is 10 plus last 2, we will store 2. Simply here we will get the reverse as 1 to 1, and our original number is also 1 to 1. So this is our reverse logic, this is our original number. So we'll try to compile it, check for the three cases. It's giving false for 1 to 1, expected to be true. What might be the possible reason? Let's check our code. If x is negative, then return false. That is true. Storing original in x, reverse at 0. While last, okay, here the logic is good. X not where we have to compare original number with the reverse. Yes, we are already cutting the x. So x is currently hampered. Now this will compile error in line of 69. No worries, let me check. undeclared identifier original. Oh, here is the spelling mistake. This will work now. Everything looks fine. Yes. Let's try to submit it. Again, it's giving a runtime error of overflow. So we will learn many things because we are multiplying the reverse with 10, so it can overflow. So what we can do? Simply, we, instead of integer, take long long. Now this will not overflow. No integer overflow. This will be submitted successfully. Yeah. So at every time we are cutting the x, so time complexity is big of log n, and space complexity is big of 1, as we have not used any extra space. So thanks for watching this video.